So to try making an equation in the spreadsheet and then importing it as a spreadsheet file as a spline into Fusion 360, I thought it would be cool to try maybe doing a golden spiral, where the kind of like you see approximated by seashells and galaxies and stuff like that, where the distance from the origin grows exponentially with respect to the angle. Let's go ahead and try doing this in a spreadsheet. What I did here, I'll repeat it over here. And note, if you don't have Microsoft Excel, OpenOffice has a similar spreadsheet program, I believe. Was first type the number 1 in your first column, and now you can hold down the control key and drag at the bottom right there, and it adds 1 to each consecutive number. And in the next column, let's do a simple equation to maybe jump a little bit so we don't have such a fine resolution. Although I did find Fusion 360 handles large numbers of points perfectly fine. So I'm going to say equals, in this case it's H is the column, and the row is 1, times, let's say, 15. Okay, so now you just click on the bottom right without holding the control down, and it will repeat in that equation. You can see here now for the second row it's doing H2 right here, which is correct, and so forth. I notice when you update things, you got to be sure that all the columns update, and if they don't, you need to drag again from the bottom right to get new values, but it should normally update itself. In the next column, what I did was I want to convert this to radians. So this is basically like, let's say, degrees now for the angle. And to convert to radians, it's just going to be pi, which is about, so let's say the column I1 times 3.14159 is, as far as I know, pi, divided by 180. And then we're going to hit enter and then click and drag to repeat that formula for the other rows. Okay, what's the next thing here? So now I did this equation, which was our exponential equation for the spiral, the golden spiral. So let's see, it looks like it's going to be 0.306. Yeah, so if we go back, it talks about in radians that exponential constant is about 0.306 to get a nice golden spiral. So you just say equals, so you can look here for the functions if you got Excel, and I got it under math and trig, and you should be able to find the exp, which is just you can also type it as exp and then parentheses. So, and then the argument is going to be 0.306 times J1 in my case, that right there. Okay, but then I need to go back and further say times cosine, COS, of our angle. Oops. So J1. This section gives us our radius, but then we need to, for Fusion 360, convert our coordinates to like Cartesian. So we need x, y, and z coordinates. So to get the x coordinate, if you remember, like in a right triangle. So in a right triangle, if this is our y-axis, this is our x-axis. You have to excuse the artwork here, and this is our r, which we just calculated. To find the side here of this rectangle, this is our angle, which is described by this column here. So it's going to be the angle, it's going to be the cosine, so adjacent times the hypotenuse. So cosine of this angle times the hypotenuse will give us the x, and then the sine of this angle times the hypotenuse or radius will give us the y. So that takes care of that, and then I'm just going to click that bottom right corner again to carry out the calculations for the rest of the column and or the rows, and then I can copy this. Let's see, you gotta be careful. So copy, I'm going to copy, hit enter so I don't mess that up, then paste into here and change this to sine, and click and drag those. Now, so here's our x, our y. For our z, we're just, let's for this case just use all zeros. Excellent. And we can get a preview by selecting those and doing a chart here. Okay. Yeah, so that looks good. The it's getting confused by the z because it's not, but we can see the blue is a good spiral that goes around a decent amount. And you got to watch out with this exponential, you know, like down here you can see the values start growing quite tremendously exponentially for if we just keep on going with the angles. But okay, so now I'm going to copy these and create a new spreadsheet and say paste the values. Okay, and now let's save this as a CSV, I guess, comma delimited. Okay, and just call it what you want. Yes. All right. To import this, go to this file and scripts here. Go ahead and choose this funny looking import spline CSV. Find your CSV file and hopefully it should be able to import it. Let's go ahead and make a loft by first creating a plane along path under the construction planes. I slid that to the end of that path, did another. I'm sliding this to the end of the other end of the path, and let's go ahead and do a sketch now on one of those planes. I'll go ahead and do whatever I want. Now we can get a lot fancier later, but for now let's just do something like an ellipse. Now I'm going to select this ellipse, and I'm out of the sketch and I can still do it. I'm going to copy it. Now do another sketch on this other plane and go ahead and paste this ellipse, and then I can do a point-to-point move of the center of the ellipse. So point-to-point move, choose the center, the end of that spline. Alright, what's next? Yeah, let's make this ellipse smaller with an offset. Looks good. Now for the fun part, to actually do the loft, I'm going to choose a loft under the Create tab and choose the two end profiles. Now we can get fancier with other rail imported CSV geometries, but for now I just used that single spline path I selected as well. So I selected the two profile faces and along with the spline path, and that made the loft. And I just decided to try adding some fillets to the end here. I found it's really better to directly type in for fillets and stuff like that instead of using that slide arrow. Just try typing in numbers directly. This is a pretty awesome thing to import mathematical paths and whatnot like this, and really look forward to using it in the future for stuff.